What?
Okay, quiz 5B, question A is asking us for a confidence interval. Now, confidence interval, best guess, plus or minus, some room for error. Except this time we're dealing with percentages instead of means. So we just need to use a slightly different formula. The formula we're going to be using is your P sample plus or minus, again, Z star being whatever the confidence interval Z is, and then your SE percent, which has a slightly different formula, which we'll show. So P sample, bottom line, very straightforward. You take number of successes out of number of cases. So in this case, it's 18 out of 19 gives you this percentage. But one thing to remember in confidence intervals is you need to find this P tilde. The purpose of this is just to bring your results slightly closer to 50%. So that's why you add 2 to the successes and 4 to the number of people or number of trials. So in this case, we get 18 plus 2 is 20, 1319 plus 4, 1323 gives you this percentage of 0.015117. Now you need to calculate P sample, and this is why we calculated P tilde, because you need, SE percent. You need to calculate your SE percent, so you need your P tilde for that. SE percent is P tilde times 1 minus P tilde over N. So when you plug in for that, you get this value of 0.00336. So now we have all the pieces that we need to fill in this formula. So coming over here, we've got your P sample right there, plus or minus. He asked for a 94% confidence interval in quiz 5B. Slightly different number than we're used to, so that's why your Z is actually 1.88, if that doesn't look familiar. And then 0.003366 coming from your SE percent. Solve that out, watch your rounding, you get 0.73% to 2% as your confidence interval. Okay, so continuing with 5B, quiz 5B, part B. One of the main things here, make sure you have your inferences, your different hypothesis tests laid out. Make sure you know which one you're doing. In this case, we're being told to do you're doing a hypothesis test for 2 populations, which means you're testing to, 2 population percentages, which means you're testing to see if the 2 populations have the same percentage or not. Therefore, we establish our null hypothesis that the percent depression in the 2 groups, AHE and NA, are actually the same, and whatever variation comes is completely by chance. So the first thing you want to do before you start this question, make sure that you have the sheet, the inference handout that he put online really helps you out for this one. So first thing you need to do, you need to calculate P pool, which is this formula right here, N1 P1 plus N2 P2 over N1 plus N2. Basically, it's number of successes between the 2 groups plus the number of trials between the 2 groups, which is why P pool is really straightforward. It's actually 16 plus 4. Just to make it clear, I established N2 as the non-addicted group. So 16 who were the depressed in the addicted group, 4 who were depressed in the non-addicted group over the total, which was 18 plus 18, so 36, gives you your P pool. So between both populations, there's about 0.5556% chance. Now the next thing we need to find is the standard error. Particularly we need the standard error of the difference. If you remember a few problems ago, we had something which was SE square root of N times P minus 1, so, or opposite way, 1 minus P. So you can see that the 2 of these are really similar. It's just that you're dealing with percentages here. That's why that formula is slightly more complicated. But in practice, it's still the same. So it's equal to your P pool, which is 0.5556 times 1 minus P pool, which is 0.4444 times 1 over N1 plus 1 over N2. That's 1 over, so it's equivalent to 2 over 18 when you sum those 2 up. We're taking the square root of that, which is equal to 0.165635. So now we've got a standard error to work with, and we just need to see what the difference is. So the z-score makes note of the difference, and then divides it by the SE of the difference, makes sense. So you get P1, which was calculated over here, 0.8889 minus P2, which is 0.2222 over 0.1635635, which is equal to a z-score of, I'm sorry, these two should be switched, although it doesn't really make a difference in the end. So it's 0.2222 minus 0.8889. So then you get a z-score of negative 4.02491. Now, just a few things before we move on. P1 is just 16 over 18, which is your depression rate for the addicted, versus 4 over 18, which is your depression rate for the non-addicted. So that's just where we got those two values from. Okay, so now we have the z-score down here. So we know that's a kind of extreme z-score. Probability is less than 0.05, therefore p is less than 0.05. So we reject the null hypothesis. So the bottom line is our conclusion is that there is a statistically significant difference between the IA and NA groups in terms of percentage of depression, which leads us into question C. We should all be able to get this by now. Even if on a quiz you don't know, just say that association is not causation, anything like that. There could be a lot of other factors that are affecting it, and that's the bottom line.